All right. Hey, what's up, you guys? Welcome to another day of Living Environment. I am your teacher, Ms. Parsons, and today we're looking at Unit 1, Scientific Inquiry, Day 4. So let's go ahead and get started. Today's aim is what are the components of a good scientific experiment? So before we talk about what the components of a good experiment are, I do want to draw you guys' attention over to part A, where you'll be watching a video on theories versus laws. That may help you understand the do now question a bit better. So I'm going to give you an example of a theory. So an example of a theory is the theory of gravity. Right? So gravity is a theory. It states what goes up must come down. Gravity makes a prediction about something that might happen in our world. Gravity is a scientific theory. Typically, the word theory, for example, you might say, if a friend of yours is running late to class, I have a theory that his alarm didn't go off this morning. Now that might be true. However, that theory is perhaps supported by some evidence, but does not meet the criteria for a scientific theory. However, the theory of gravity has been tested and confirmed by many different experiments, right? So the theory of gravity says that what goes up must come down. We can test that theory. What goes up must come down, gravity. So, what is a fact? The paper fell, right? The paper fell when I dropped it. That is a fact. That supports the theory of gravity. We could test that theory 5,000 times, and 5,000 times out of 5,000, if we were on Earth, the object would fall. So another example of a fact could be this bottle is white. This is an iPhone, right? So a fact is irrefutable and it is based on its state of being. A fact doesn't have to connect different interrelated things. Instead, a fact is a fact. However, theories may connect or predict facts. So now, I'm not going to show it in this video because otherwise my video would get taken down for the copyrighted content, but please pause this video and open up the link to the Amoeba Sisters here. Great, okay, so in that video, the Amoeba Sisters talked about scientific theories versus scientific laws. So please make sure if you did not watch that video, you go ahead and watch the linked video. And now let's go on. To part B. Base your answers to questions 1 and 2 on the information below and on your knowledge of biology. African violet plants are grown for their delicate, colorful flowers and furry, soft leaves. People often want to touch the leaves and brush the hairy leaves with their fingers. Growers and plant owners were concerned that this could negatively affect the plant because so many people were touching the leaves. Of particular concern was the presence of body lotion or other skin products on the hands of persons touching the leaves. A student thought that this might be the basis of a science project. He selected 2 African violet plants, 10 leaves, pardon me, excuse me, don't worry guys, sneezing is not a symptom of the coronavirus. Unless in the future it's found to be a symptom of the coronavirus, but moving on. So, of particular concern was the presence of body lotion or other skin products on the hands of persons touching the leaves. A student thought this might be the basis of a science project. He selected 2 African violet plants. 10 leaves on each of the 2 plants were brushed with a gloved hand for 30 seconds. So now here we're setting up the experimental design. He selected 2 African violet plants. 10 leaves on each of the 2 plants were brushed with a gloved hand for 30 seconds, once a day for a period of 5 days. Gloved hand, 30 seconds, once a day for a period of 5 days. That's our experiment. The difference was that the leaves of the second plant were brushed with a gloved hand that had lotion applied to the glove. So here, this is the lotion group, and then this other group is the control group here. Describe the type of data that should be collected to determine if the brushing with lotion was having a negative effect on the African violet plant. So let's go back to the experiment. And in this case, there could be several correct answers. So what is the type of data? You could say, for example, number of leaves, petals. So this is asking for you to provide an example of the type of data. So we could have quantitative data. We count the number of leaves or petals on the African violet plant to determine if the plant is as healthy on day 1, or excuse me, it is as healthy on day 5 as it was on day 1. You could also gather data by photos, sketches of plant color. But in general, we want some quantitative, meaning numerical, or qualitative, meaning subjective. So the plant looked wilted, documented with a photo on day 5 compared to day 1. And these are the 2 different types of data that we can gather in an experiment. And question 2, state one possible hypothesis for the experiment proposed by the student. So if an African violet plant is touched by a lotioned hand for 5 days, the plant will die. You could also say will decrease in size, will lose petals, will lose leaves. But in general here, these questions are looking for your ability to analyze an experimental paragraph. So this is a description of an experiment. Based on this short description, can you pick out what did the experimenter do? What kind of data would they need to gather? What is the beginning, middle, and end of this experiment going to look like? But don't worry if you had a little trouble with this first one, because we're gonna go on and do it again. Part C, deer ticks. Base your answers to questions 3 through 5 on the information below and on your knowledge of biology. Ticks, such as deer ticks and dog ticks, feed on the blood of humans and other animals. Part of the feeding process involves the tick injecting its saliva to help make blood flow. In the process, they sometimes spread disease organisms to their host. So the tick injects its saliva and then that sometimes spreads disease organisms to their host. Sometimes ticks get on clothing and can remain there for days before actually biting their host. A scientist found that ticks might be able to survive even when exposed to hot water and detergent in a washing machine. So the ticks could stay on your clothes and live after going through the wash. Students designed an experiment below to test how well ticks survive a hot water washing machine cycle with detergent. Note that some of the details of the design are incorrect. So the hypothesis says, can ticks survive a hot water and detergent wash cycle in a washing machine? So that could be your question, right? Because is that a hypothesis? The hypothesis would make a prediction. The hypothesis would say, yes, the ticks can survive The data to be collected, the number of ticks surviving the cold water wash cycle. Uh-oh. It says here we're testing them in hot water washing machine cycle. So is the data going to be the number of ticks that survive the cold water wash cycle? No. The test subjects, deer ticks versus dog ticks, right there, that's not going to be good, right? Our experimental group and our control group need to be the same type of organism. The only thing that needs to get changed, or that should be changed between the control group and the experimental group, is the experimental condition. In this case, in the experimental setup, the control group is getting washed with cold water and detergent, which is fine if the thing that's being tested is hot water. And it says here the control group, cold water and detergent, the experimental group, hot water and detergent. That is okay. But then you go below the number used. You want to have the same sample size for your control group and your experimental group. So in this case, you can see the control group is 10 ticks and the experimental group is 100 ticks. You're not going to be able to compare the data from those two experimental setups. So how can we improve this experimental setup? Identify one error in the student's design of the shaded table and explain how the student should change the experiment to correct the error. So we went through several, but how about sample size? So sample size is the number of subjects in the experiment, and correction, use same number of ticks for both. Explain why the students' proposed data to be collected would not likely test what the students intended. So the data gathered would be for cold water ticks. Student intended to test if the ticks could survive in hot water. Identify one error with the hypothesis. We already stated that the hypothesis there was a question, can ticks survive in hot water? The hypothesis should be in the form of an if-then statement. If ticks are given a hot water bath, then the ticks will die. Also, the hypothesis should make a prediction. And this one didn't, it was just a question. All right, ladies and gentlemen, what are the components of a good experiment was our aim today. In a quality experiment, we want to make sure that we have a large representative sample size. We want to make sure that our control group and our experimental group are receiving all the same conditions except for that experimental condition or the independent variable. And we also want to make sure that throughout an experiment, the data that we're gathering is consistent and valid data to answer our experimental question. But don't fear if you still have questions about what makes a good experimental setup, because we'll be talking more about that in tomorrow's video for Scientific Inquiry Day 5. All right, ladies and gentlemen, please don't forget to log in to Google Classroom to complete your exit ticket using the link there at the bottom or via your Google Classroom stream. I hope you guys all have a super fantastic day. See you all tomorrow on Zoom. Goodbye.